Question number 71. It has two parts. Let's solve part A first. Part A is a plus x, root of a plus x into dy by dx plus x is equal to 0. So given part A, root of a plus x into dy by dx equal to minus x. Now we can solve this differential equation using the method of separation of variables. We can bring all the x terms to one side and y term to the other. So that becomes dy equal to minus x by root of a plus x dx. Now we can integrate this. So dy equal to integral minus x by root of a plus x dx. So this becomes plus constant, so this becomes y equal to, so we can write this integral taking minus outside, a plus x minus a by root of a plus x, so dx plus c. So this becomes y equal to minus of, let's minus outside, so integral root of a plus x dx. Since a plus x by root of a plus x is root of a plus x dx minus integral a of a by root of a plus x dx plus c. So these two can be easily integrated. So that becomes y equal to minus of root of a plus x becomes a plus x raised to 1 by 2. So 1 by 2 plus 1, 3 by 2 by 3 by 2. Also here this becomes minus a into a plus x raised to minus 1 by 2. So minus 1 by 2 plus 1 is plus 1 by 2, a plus x raised to 1 by 2 by 1 by 2 plus c. So that is simplifying, we get y equal to minus 2 by 3 a plus x raised to 3 by 2 plus a into a plus x, 2a into, so plus 2a into a plus x raised to 1 by 2 plus c. So now we can take, for simplification, we can take a plus x raised to 1 by 2 common and 2 by 3 a plus x raised to 1 by 2 common. So that gives, so let's take minus also, minus 2 by 3 a plus x raised to 1 by 2 common. So this part is gone, so it becomes a plus x. So reason being, this is nothing but a plus x raised to 3 by 2 means root of a plus x the whole cube. So when we take root of a plus 1 root of a plus x outside, it becomes root of a plus x the whole square. So that is a plus x. So yeah, root of, so a plus x and we took minus 2 by 3 out. So let's multiply by minus 3 by 2. So minus 3 by 2 because minus 3a plus c, or y equal to minus 2 by 3 a plus x raised to 1 by 2 into a plus x minus 3a is x minus 2a plus c, or we can write y plus 2 by 3 a plus x raised to 1 by 2 into x minus 2a equal to c. So this is the solution to part A of question 71. Now we will do part B. So to do part B, I'll copy this to a new page. So this is our equation. Now let's rewrite this. Dy by dx equal to minus of root 1 minus y square and root of 1 minus x square. So we will use method of separation of variables and bring all the y terms to one side and x terms to the other. So that gives minus 1 by root of 1 minus y square dy equal to root of 1 minus x square dx. Now we can integrate both sides, giving minus integral 1 by root of 1 minus y square dy is equal to integral root of 1 minus x square dx. So these two integrals are in standard forms. I'll just show you the standard forms. So just remember, this is in the form 1 by root of a square minus x square, and this is in the form root of a square minus x square. So the standard forms are for 1 by root of a square minus x square, the form we will use this formula 27, integral of dx by root of a square minus x square is equal to sine inverse x by a. And for the formula for the next one, we will use root of a square minus x square, which is this one. Root of a square minus x square, integral of root of a square minus x square dx is equal to x by 2 into root of a square minus x square plus a square by 2 into sine inverse x by a. So this is the standard formula. You can easily derive it. So if you remember such standard formulas, that will come handy to solve questions in exams. So I'm going back to our question. So I will just, one second. So this is our question. So I will just note down the standard formulas here for simplicity. For 1 by root of a square minus x square is equal to 1 by a sine inverse x by a, and integral root of a square minus x square is equal to x by 2 into root of a square minus x square plus a square by 2 sine inverse x by a. So let me just cross check whether I have made any mistake. Sine inverse x, there is no 1 by a here, that was a mistake. Okay, and for this formula there is x by 2 into root of a square minus x square plus a square by 2 into sine inverse x by 2. So that is correct. So here the mistake I did was there is no 1 by a here, just sine inverse x by a. So we can derive this equation. If there is any confusion, we can derive this in equation by putting x is equal to a sine theta. Say x is equal to a sine theta as a substitution, and then deriving, solving the derivative, we will get this equation. So that is one way to approach. So yeah, so this is the standard equation. So let's use it to solve our question. So we had minus 1 by root of 1 minus y square. So it gives minus of sine inverse here y is equal to, so this, let this be equation 1. So 1 becomes minus sine inverse y is equal to, now root of x by 2 root of 1 minus x square plus a square by 2 is just 1 by 2 sine inverse x. So this is the solution to the given question. So there was slight mistake. So this question will have this answer. There is no mistake here, but there was a small mistake when I wrote down the question. So it was by 1 minus y square by 1 minus x square. So it was by 1 minus x square. So the whole thing changes. We'll do one thing. We'll do that question as another question, part C. Let's say part C. So this question, if it was like this, it will have this answer. So our question is slightly different. So we'll just do one thing. We'll do that as a different question. So just going to a new page. So if our question was by, let's solve that question C as part C. So part C is this, that becomes dy by dx equal to minus root of 1 minus y square by root of 1 minus x square. So it becomes like this. So proceeding like before, we get minus 1 by root of 1 minus y square dy equal to 1 by root of 1 minus x square dx. Then our equation becomes a little more easier when we integrate, say minus 1 by root of 1 minus y square dy equal to integral 1 by root of 1 minus x square dx plus c. So this is sine inverse, integral is minus sine inverse y, and it is sine inverse x plus c. So our equation becomes c sine inverse y plus sine inverse x is equal to, instead of c minus c, I just write c1. So this is the solution to that question. Sine inverse x plus sine inverse y is equal to c1. So there was a it was 1 minus y square by 1 minus x square. I wrote instead as product. So in that case, we will get like this. So this will be the answer. Okay, so these can be considered as 3 parts. Then question 71, A, B and C. So this is the solution to question number 71.